Okay, so today we're going to cover geometric sequences and series. Okay, we did arithmetic sequences and series. Arithmetic ones have a common difference. Okay, now we're going to look at geometric sequences and series. Remember, one thing we said yesterday was that sequences are separated by commas, okay, between the terms, and series are separated by plus or minus signs between the terms. Okay, so if we look at a new sequence today, like 3, 6, 12, 24, and then show the 3 dots to show that it continues on. First, you should check, is it arithmetic? Is there a common difference between each term? So you'd take 6 minus 3 is 3, 12 minus 6 is 6. No, there's no common difference. But is there a common ratio? If you take the second term divided by the previous term, you get 2. If you take 12 divided by the previous term, 2. 24 divided by 12, you'd get 2. So there's no common difference, but there is what they call, in this case, a common ratio. Okay, 2 would be a common ratio, and they will abbreviate that with just the lowercase r. Okay. The formula for geometric, for finding a like the nth term for geometric sequence, is a sub n equals a r to the n minus 1 power. Okay, and that's the formula. The a sub n is still the nth term. A is the first term, r is the common ratio, and n is the number of terms. Okay, so let's look at an example. Say they ask you to find the 5th term of the geometric sequence. Find the 5th term of the geometric sequence, and the sequence is 54, negative 36, 24, and show the 3 dots. Now, you could just find the common ratio, and if you look back up here, to go from 3 to the next term, you would multiply by 2 to get to 12, multiply by 2. That's one way, but if I ask you to find the 500th term, you don't want to have to do it that way, so you need to know the formula. Okay, so use the formula a sub n equals a r to the n minus 1 power. We want to find the 5th term, so that's a sub 5. The first term would be 54. Common ratio, you have to figure negative 36 divided by the previous term, and just reduce it. 9 would go in there 4 times, 9 in there 6 times. We can reduce it again to negative 2/3. If we took 24 divided by the previous term, the order that you do this, it's always divided by the previous term. If we reduce by 12, would give us 2 over negative 3. So negative 2/3 is our common ratio. So substitute that in. And the n is 5 because they ask us to find the 5th term. Now you go to the order of operations. PEMDAS, please excuse my dear Aunt Sally. And redo the parentheses, then the exponents, then the multiplication or division, whichever comes first as you're going left to right, and then the addition or subtraction from left to right. So we want to go over and do the exponents first. Do the negative 2/3 to the 4th power. And if you simplify that, leave the 54. The negative, now you want to be careful on the calculator. On the calculator, if you're going to do this on the calculator, if you do negative 2 to the 4th power on the calculator, it's going to give you the wrong answer, negative 16. Because the calculator is doing order of operations. It's doing negative 1 times 2 to the 4th, which is a negative 16. If you want negative 2 to the 4th power on the calculator, you've got to put it in parentheses. A negative to an even power ought to be positive. Okay, so it would be positive 16, and 3 to the 4th would be 81. Okay, and this is like 54 over 1, and then reduce it. 9 would go into 54 6 times. 9 would go into 81 9 times. We can reduce it again. 3 would go into 6 2 times. 3 would go into 9 3 times. Then multiply across on top. We've got 2 times 16 is 32, and 1 times 3 in the denominator, 32 thirds. Okay, and that is our final answer. Okay, the fifth term is 32 thirds. We could have gone up here and just taken a negative 2 thirds times 24, take that answer times a negative 2 thirds. But like I said, if you're asked to find the 500th term, you don't want to have to do it that long way. You need to know the formula. Okay? Okay, that is the formula for an arithmetic sequence. Okay? Or not an arithmetic, sorry, geometric. Geometric sequence is a sub n equals a r to the n minus 1. And if it's geometric, it has a common ratio. If it's arithmetic, it has a common difference. Okay, so the next thing is the sum formula. And this is the sum of a finite, okay, and that's a key word, sum of a finite geometric series. And remember, the series has plus or minus signs in between. Sum of a finite geometric series. And the word finite means it has an end. I might give you an infinite geometric series, but as soon as I say find the sum of the first 10 terms, then I've chopped it off, I've made an end to it, it stops, and the formula, still an S sub n, because keyword is sum, okay, and it would be a minus a r to the n power over 1 minus r. And that's the formula for a finite sum of a finite geometric series. If you look on the top part here, what's in common, you could factor out an a. Some authors do this and write it, there would still be a 1 minus r to the n power, and it's all over 1 minus r, and r cannot equal 1 because you'd have division by 0. Okay? So if they ask you to find the sum of a finite geometric series, that's the formula you use.